test, blah, blah, blah. Yeah, we had mentioned that the test was going to be towards the end of this week. What I'm looking at doing is we're going to finish 6-7 today. That gets us to do the graphing and writing equation stuff of 6-8 tomorrow. God, I hate to think of this. We might do the, you want to do calculator or non-calculator Friday, and then do calculator or non-calculator Monday?
Wait, what's the non-calculator?
What the non-calculator would probably wind up being is what you did yesterday. Synthetic stuff without a calculator.
Well, yesterday.
So I'm kind of toying with the idea because there is some modeling stuff that we're going to do, but it doesn't relate. You know what? Actually, it'll work out fine. Let's do this. Let's set it up for Tuesday. We'll do. We've got the writing of the functions today, graphing tomorrow. We'll work on the word problems on Friday. Monday, we'll do the review junk. The last 15 minutes of class on Monday, you'll do the non-calculator problem that I'll come up with. And then on Tuesday, you'll take the regular test and with calculator. Okay? Does that work? Yeah, we have school on Monday. Yes, ma'am.
What's like going to be on the test? Like,
Polynomials.
like all this stuff?
Yeah. We'll get into it when we get towards the end here. I'll show you, okay? So the last little bit here is going in reverse. What we're going to do today is we're going to write the polynomial given zeros. And we've been talking about this all along. If I give you these 3 zeros, I want you to write out the polynomial. So if I tell you your zeros are at 3, 0, and -2, you have zeros at 3, 0, and -2. What are your 3 terms? X minus 3. And what do you do now? Foil out. That's it. So for shortcut wise, can I write this as, and then just foil? Will that work? So we have x cubed. And there's your function. You wrote out the polynomial function with the given 3 zeros.
So that's it?
That's it.
We just have to like find it out.
Yeah. And if you think about it, what we've been saying all along is that I've been training you guys, yes, this has been a little bit of work in progress. Anytime we wrote down a 0, what I'd ask you, what's the term? And every time we had a term, I would ask you, what's its 0? I was setting you guys up to be able to do this real quick. Yes, ma'am?
Is x minus 3 the term or the 0?
X minus 3 is the term because 3 is the 0. Yeah. So we've been working on this process all along. But what's going to be weird is when you have imaginaries.
Oh.
Imaginaries and duplicates. So let's take a look at this. Maybe, or maybe not.
That's solid.
Don't you just put them in like x?
Well, take a look what we have here. How many zeros do we have given to us?
4.
What should be our degree of our polynomial then?
4.
4. We should have a 4th degree polynomial. If I have zeros at x at 1 and 1, that means my terms are x minus 1, x minus 1. Everybody okay with that?
Yeah.
Now, what's your term going to be when it's
X squared
X squared plus 1.
x squared plus 1? Good. We okay with that? Could you have written it out as x minus I, x plus I, and then just FOILed it from there as well if you'd like? You'll get the same result. Okay. So it's just a matter of FOILing out. Now, you should know what this is off the top of your head. X squared minus 2x plus 1. And then just continue just to distribute. X to the 4th minus 2x cubed plus x squared minus 2x plus 1 gives us final function of x. Oops. And make sure you write it in a nice descending order. And you're done. Okay. Excuse me. The weirdness comes in. Of course, it gets even a little bit weirder. Wait, I heard someone say what? Let me ask you this. When you get into something like this, sometimes they're going to write it out as 2, -3, and I.
Yeah.
If you have an I, what else do you have to have? Negative I. You can't just have one of the values of I. You have to have one of each. You see what I'm saying? Why is that? Because how do you get I? Square root of negative. And in order to do that, you had to have a squared term, right? So sometimes the book tends to put just one of the values. That means you just have to work with both of them. So just remember, if you see one of them, that means the other one has to be there. Does that make sense? Okay. Now, the weird one. You want to finish this one while we're at it? Or why don't you guys finish that? Take a second to finish that one out, and I'll show you the weird one in a second. Oh, it's a different one. I was just double checking how to do the weirdest of the stuff. So everybody okay with x minus 2, x plus 3, and then x squared plus 1? You okay with that? So as you go through, you get x squared plus x minus 6. What's that? So your f of x will equal x to the 4th, x cubed, negative 5x squared, and x to the 6th. All right with that? All right. The weirdest of them all comes into play when your I value isn't just I. If it has a coefficient with it, or if it has 3 plus I or 3 minus I, something along those lines. For example, this is as weird as this gets. Let's say you have 3 minus I, 3 plus I, 5I, and negative 5I. Yes, ma'am? Yes, exactly. If you have one of them, you have to have the other. Now, what I want you guys to remember here is what these are actually are. These are zeros, right? So when you start to think about it, what you're looking at is each one of these would be x minus 3 minus I. Think about what it is. If your other 0 was 2, it was x minus 2, right? So it's x minus that jump. X minus that jump. X minus that. X minus that becomes this. All I'm doing is just do the same thing. It just so happens that instead of being 3, negative 3, 5, negative 5, she'll be x plus 3, x minus 3, and so on. What I'm looking at here is I'm subtracting that term. That's how I'm getting these zeros. The weird part comes in now in when you have to simplify here and here. In order to simplify that, it's just a matter of distributing your negative. Let me show you what happens. You wind up with x minus 3 plus, plus I. You okay with that?
Yeah.
All right. Here you have x minus 3 minus I. You okay with that?
Yeah.
Okay. Now, is there any rule that says that I cannot do this?
No, I'm not gonna know.
I know it either. Because the reason why I want to do that is that I'm grouping them. I'm going to try and group them because what would happen is if I group those together like that, if I started to FOIL, is this a weird way of showing that? Is that a weird way of showing a plus b, a minus b? If you look at it, x minus 3 is a, x minus 3 is a, I. If you FOILed that out, isn't that just a difference of squares?
Probably.
Sure.
Think about it. It's the same term up on both here and here, here and here. Your signs change. When you did that, wasn't that just first term squared, last term squared? Isn't that it? Think about what you're doing. Think about the way it looks. When you worked your stuff through, if you FOILed that out, if you FOILed this out, let me go over here. If I take all this and FOIL it, you get that, right? And then it'd be minus I times x minus 3 plus I times x minus 3 minus I squared. Do you agree?
Yeah.
What happens to those middle terms?
They go away.
They go away. Therefore, it mirrors that exact same pattern. It just looks funky. Okay? The nice thing is that this is one of those processes that kind of replicates itself every time. Okay? Once you set it up once, it does the same thing each consecutive time, just with different numbers. So now you wind up with those. But what's the other one then?
X squared plus 9.
Now, if you FOILed all that out, you get x squared minus 25i squared, which is x squared plus 25, right? So here's the weirdness. What's I squared?
What? Negative 1.
It's negative 1. So this is x minus 3 quantity squared plus 1. Do you agree?
Yeah.
What's I squared? So minus a negative 1 is plus 1. And then it's still times the x squared plus 25. This becomes x squared minus 6x plus 9 plus 1. Boiling out that first part. We'll do another one with different numbers here in a second. Then you wind up with x squared minus 6x plus 10 times x squared plus 25. Okay. The weirdness here is because of the grouping that you do at the beginning with the imaginaries. All right. What happens is you remember that each of these terms, it's x minus this, x minus this, and then this one was the easy one. You regroup them. You FOIL them to wind up with a trinomial minus an I squared. Okay? And that's where you get that plus 1. Yeah, I'll go with that. All right? I'm going to do another one like that. Very similar. I just changed the number though. The pattern itself doesn't change for how it works itself through. The weirdness is just having to deal with that I squared. Okay? Can I make up another one real quick? All right. So we did what? 3 plus I, 3 minus I? So let's do this. Let's say it's 2 minus I, 2 plus I, and then 3I, and negative 3I. Once again, what happens if they do this? What do you,
This is negative.
you have to assume that the other one is there? What happens if they do this? You have to assume the other one is there as well. Okay. All right. So again, as you go through this, your zeros become, well, the x minus the quantity 2 minus I, x minus the quantity 2 plus I, x minus 3I, parentheses, and x plus 3I. Okay? The stuff on the right is usually the easier to work with. Does everybody agree you wind up with x squared plus 9?
Yeah.
Okay, like I said, that's the easy one to deal with. So here you're going to get x squared plus 9. I know that's going to happen. On the other side, what I want you to do is, again, just regroup it. X minus 2 plus I. X minus 2 minus I. What's that? Why is it a plus I? What's negative times negative? What I'm doing here is I'm taking this negative 1 and I'm distributing it to both terms to move to regroup them. Yeah. What
Is that 1 or
do you mean?
like what is I?
I is nothing. I squared is negative. I is just the imaginary number. I squared is the square root of negative 1. Oh, excuse me, I'm sorry. I said that backwards. I is the square root of negative 1. I squared is negative 1. So when you FOIL this out, When you FOIL this out, you get the quantity x minus 2 squared minus I squared times x squared plus 9. So you wind up with minus -1, which is positive 1. So you FOIL this one out, you get x squared minus 4x plus 4 plus 1 times the x squared plus 9. And then just distribute out. Okay? Notice what we did again was that we just set it up as x minus 2 plus I minus I. It's the same thing every single time because of the way the values are written. It's the same thing. Okay? That's all it is. You wind up taking the x minus 2 quantity squared, FOIL it, add 1, and it works. Bless you. Okay? Yes, there is. There's 2 versions of it. The first one is better than the second.
Okay, well, the Bears this year literally are bad.
I think we're great.
I just randomly thought of
I
that. I mean, I think
We're going to the Super Bowl.
we did a great cover.
We're winning 11 straight games.
Every other team is going to explode because of plane crashes.
Yeah.
That's kind of morbid. I'm sorry. That's kind of mean.
Hey, we learned about that in speech. Someone did their informative speech on that football team.
Marshall?
Yeah.
That's a movie, we're Marshall.
Yeah, they all died.
Yeah. Except the coach that
Oh,
somehow
yeah.
was like, no, you're not. And then he
I'd like you to do. So this is the same. This is the next page over. So this is 370. It's still section 667. Let's write out the ones from 39 to 46. All right. Oh, what page is that? 370. 39 through 46. I'll write it down. So this is 6, 7. Okay. Let's do those extraordinarily. You're not going to be taking this in the back. I know, I'm joking. I was being the sub. Take a deep breath. Jeez.
Calm down.
All right. We'll go through those. Tomorrow we'll graph. All right. Tomorrow we'll graph. We'll do some cool stuff with that.